Okay, I'm here with Andrew Ash from CSIRO's Climate Change Adaptation Flagship. Andrew, help us to understand, just in simple terms, what is the greenhouse effect?
That is, greenhouse gases are an important part of our atmosphere, and without greenhouse gases in the atmosphere, our planet would be about 33 or 34 degrees centigrade cooler than it is now.
Doesn't sound good.
So they're really important. Of course, if we start to increase those greenhouse gases through human activities, we increase what's called the radiative forcing. So, for example, carbon dioxide, if we increase that gas in the atmosphere, what it does is, as we have incoming solar radiation from the sun, it hits the earth, and some of that bounces back up, and our greenhouse gases in the atmosphere trap that outgoing radiation, some of that outgoing radiation. If we put more of those greenhouse gases in the atmosphere, they trap more of the outgoing radiation, and we start to warm the planet.
Okay, so it's as simple as that. There's kind of like a shield in a sense.
Yeah, it's like putting another blanket on.
Okay, there you go, another blanket. And what about deforestation? How does that feature in terms of the greenhouse effect?
The main effect there is the release of carbon dioxide when we clear forests.
Yes.
Quite often there's either decomposition of that material, or we burn the residue from the forest, and that releases a lot of CO2 from that vegetative material, and sometimes from the soil in the clearing process.
And presumably those trees are no longer able to absorb the CO2 that was there before.
Yes.
And so that also has an impact on what remains.
Yes, and that adds to the effect, and if there's some indications from the science, not as strong as the direct influence of carbon dioxide release from clearing, but if you in fact deforest large tracts of land, that can in its own right start to influence regional climate.
Well, that makes sense in my backyard. I've seen that. I play with my flowers sometimes. So, Andrew, this system, the greenhouse effect, works within this climate system, and that's kind of a slow-moving beast, isn't it? Because there have been periods historically where the Earth has been much, much colder and, much, much harder, but it seems to be changing quite quickly now because of the concentrations, forming very quickly. How do we think about the lag time in the system, given how quickly we're increasing the CO2 in the atmosphere?
Yeah, so when we increase the CO2, the increase in radiative forcing starts almost immediately when those gases mix, but the biggest source or sink of energy in the Earth system is the oceans.
Yes.
And they start to absorb a lot of that energy, and so that creates essentially the lag factor between when you first start to increase the greenhouse gases and the response in the planet's overall temperature.
Of course, because as the oceans then start to heat up, the atmosphere then gets hotter as a result of the oceans
you start to get
warmer.
a very tightly coupled processes between ocean and atmosphere.
It's as if we're cooking a big stew in the kitchen, except it takes a long time for the stove to heat up and for the...
So there's a lot of inertia in the ocean system, and that causes some of the delays that we see.
Okay. And also, I guess in measuring the impact of these gradual changes over time, there's a lot of variability in the system anyway. How do scientists kind of declutter the variability from the predictable trends?
Yeah, that is a challenge, and it's a challenge not just in the science realm, but for people to really understand and what we're doing into the Earth system, because at the moment the greenhouse gas signal is and it's a signal is quite a modest trend, say, on temperatures going upwards, but we have a lot of natural variability in our climate system also. So you've got more year-to-year variability or noise than signal. So we've got a high noise-to-signal ratio, and that can often mask the long-term effects of warming that we see. For example, the last few years we haven't seen as much warming as in the previous decade, and that can in part be attributed to just the natural variability.
So if you look over time, it kind of goes like this, and you can see, and we're just going like this, and presumably...
And as a consequence, some people argue, well, CO2 has been going up quite a bit in the last decade, but temperatures haven't been increasing at the same rate. But the overall trend, if you take a longer-term trend, and you need to look at longer-term trends, that 30-year trend of warming is continuing. And it's probably, analogy to this on a much shorter time cycle might be that as we head towards summer, this week, for example, was cooler than last week.
Right.
That doesn't mean that summer's not coming. It's just the variation from week to week means that not every week as you head towards summer is warmer than the previous one.
Okay, fair enough. Thank you very much.